Okay, continuing with chapter 8, the last section, section 8.8, and the study check problems at the end of the chapter. I wanted to go through the solutions of each of these problems, so we'll go one by one. So the first one was, I have a balloon with a volume of 4.5 liters, pressure of 567 millimeters of mercury. What will the new pressure be when the volume is reduced to 2.5 liters? So this is just a Boyle's law problem. So P1 V1 is equal to P2 V2. Okay, so the setup is, that's the initial pressure, this is the initial volume, and you have to determine what the final pressure is. So dividing both sides by 2.5, P2 will work out to be P1 V1 divided by V2. So 567 times 4.5 divided by 2.5, liters will cancel, and you get 1020 millimeters of mercury. The second problem was, you have 15 mils of gas is collected at 25 degrees centigrade and 650 millimeters of mercury. What is this volume at STP? So you'll use the combined gas law formula, P1 V1, and this is the form I suggested you use because it's easy then to do the conversion and the determination of the unknown. So P1 V1 T2 is equal to P2 V2 T1, right? So 650 millimeters of mercury, P1, 15 mil V1, and then the T2 is, standard temperature is 273 K. Standard pressure, P2, is 760 millimeters of mercury. T1 is 25 plus 273, so 298. We have to solve for V2. Okay, so if you divide both sides by 760 times 298, to get rid of that, you solve for V2 and you get 12 mil. All right, the next problem was 2.5 liters of gas at 64 degrees centigrade and 700 millimeters of mercury is now subjected to a temperature of negative 33 degrees centigrade and a pressure of 900 millimeters of mercury. What is the new volume? Again, combined gas law problem. So the formula again is P1 V1 T2 is equal to P2 V2 T1. So you have 700 millimeters of mercury, 2.5 liters, and then T2 is negative 33, so that works out to be 240 K. The final pressure is 900 millimeters of mercury, and the final temperature, when you convert this to Kelvin, is 337 K. So you're solving for V2, the final volume. Okay, so divide both sides by the 900 times 337, and so that works out to be, V2 works out to be 1.4 liters. And the final study check problem was, an unknown gas having a mass of 5.5 grams is collected in a 4-liter glass bulb. It's found to have a pressure of 400 millimeters of mercury and a temperature of 27 degrees centigrade. How many moles of gas do you have? What is the molar mass of the gas? So I decided to convert the 400 millimeters of mercury into atmosphere so that I can use the gas law constant of 0.0821. So 0.53 atm, right? And then I rearrange this, divide both sides by RT. So PV divided by RT gives you N, the number of moles. So 0.53 pressure times the volume, 4 liters, divided by the R, gas constant, 0.0821, and then the temperature is 300 K. Okay, 273 plus 27, 300 K. So I got 0.086 mole. Okay, Then I took the grams of gas, divided it by the moles, and I got the molar mass, grams per mole, 64. So the possible gas could be SO2 gas, okay, because that molar mass of SO2 would be 64 grams per mole. All right. Although the problem did not ask you to identify the gas, that's how you would do it. Take the molar mass and then figure out what the gas is. All right, the homework problems for this chapter 8.1 to 8.8, page 294, 8.9 to 8.22, page 297, 8.23 to 8.28, pages 299 through 300, 8.29 to 8.34 on page 302, 8.35 to 8.38, page 304, 8.39 to 8.46, page 307, 8.47 to 8.60, page 312, and 8.61 to 8.67 on pages 314 and 315, right? And that concludes chapter 8.